Arguments are set up in a particular way and have a specific meaning that must be translated properly to be able to find its truth values. Unlike arguments that are given in symbolic form, some arguments are given in word form as statements. To be able to find the truth values of these arguments, it is best to translate them into symbolic form, then proceed to make a truth table to find the truth values. So once we find the truth values, we have two options. We can either say that the argument is valid, where all the truth values of the conditional statement are true. That means everything has to be a T. Or we say it's a fallacy or invalid argument. This is where the truth values of the conditional statement are not all true, meaning we have at least one F. So if they're not all T's, then we say it's an invalid argument. If they're all T's, then we say it's a valid argument. So let's look at the example. If Tim and Janet play, comma, the team wins. Tim played and the team did not win. Therefore, three dots means therefore, Janet did not play. So looking at this, I can see that I actually have three simple statements. I have a P, Q, and an R. I have Tim and Janet play. So I have Tim and Janet. So those are two separate ones. And the team wins. So that would be my third statement. So I can say that P Tim played, Q Janet played, and R the team wins. Now I use past tense here, they have present tense here. That's irrelevant. You don't have to worry about past, present, or future tense typically when you're dealing with stuff like this. So now let's translate this into symbolic form. So if Tim and Janet play, so P and Q, so I could say P and Q, comma, then the team wins. So that's an implication. So implies R. So this is all grouped together. Tim played and the team did not win. So P and not R. So P and not R. Therefore, Janet did not play, so not Q. So there we go. I have it all set up in symbolic form now, but again, I'm going to translate it one more time to make it easier to write a truth table. So I have P and Q implies R. So that's the first one. And then this is, we go from the first line to second line, that's an and. So I'll use another parentheses here. And P and R, not R, excuse me. And then I'm going to use a bracket. Therefore just means implies, not Q. So now I have my fully written out statement in symbolic form. And I'm just double checking to make sure everything looks good. So now I'm going to write my truth table for this. So let's bring up the truth table. And this is a big one, but it's okay. We're going to do it piece by piece. So I have P, Q, and R already filled out, all the T's and F's. So now I'm going to fill out the rest. So starting with not Q, going to be false, false, true, true, false, false, true, and true. And then not R, so opposite of all those, false, true, false, true, false, true, false, and true. So those are the easy ones. Now let's get on to the next one. P and Q. So true and true is true. True and true is also true. True and false, false. True and false, false. False and true, false. False and true, false, false and false, false, and lastly, false and false. F. Now we can move on to the next column. So P and Q implies R, so this column here, and implies this column here. So true and true is true. True and false is false. False and true is true. False and false is true. False and true is true. False and false, still true. False and true, true again. And false and false, another T. All right, so far so good. Now we're going to do P and not R. So P and not R. So true and false is false. True and true is true. True and false is false. True and true is true. False and false is false. False and true is false. False and false, still false. And false and false and true is false. All right, two more. Now we're going to do the and statement between this column and this column here. So all of this and this. So we're going to get true and false is false. False and true, false. True and false, false. True and true is true. True and false, false. True and false, false. True and false, false. And lastly, true and false, still false. All right, that was a lot. Now we're at the end. Now it's going to be this entire column here implies not Q. So let's get to it. False and false implies false is true. False implies false. True. False implies true. True. True implies true. True. False implies false. True. False implies false. True. False implies true. True. And finally, false implies true. True. This entire column is true. So that means that our statement is valid.